All right, geometry video 2 here, covering lesson 4.3. We just talked about side angle side congruence, and now let's move on to side congruence. This is another way to prove triangles congruent. Again, side means if you know that 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So if you look here in this picture, right, A, B, and D, E, they are marked with 1 dash, so that's a pair of sides. That's side 1. BC and EF are a second pair of sides marked with 2 dashes, side 2, and then AC and DF, a third pair of sides marked with 3 dashes. If you know that those 3 sides are congruent between the 2 triangles, then the triangles are congruent. Okay, there we go. So now we're going to do a little bit of a difficult proof here of this side congruence criterion. Again, just follow along. You'll never have to do this by yourself, but they want us to show you how to do this. All right, so here we have given to us 2 triangles with 3 pairs of congruent sides. And we want to prove that these 2 triangles are congruent. And we're going to do this by using some transformations. So first, we're going to do a translation. We're going to translate triangle ABC so that point B corresponds with point E, or they line up, right? Which would mean that E is going to equal B prime, which is going to line up one of our vertices between the 2 triangles. So again, we would just slide this triangle down here so that this E would now be B prime. C would slide down here, so this would be C prime, and then A would slide down here, and that would be where A prime goes. And again, the side lengths stay the same because the translation is a rigid motion. So A prime, B prime is still having 1 congruent marking. B prime, C prime has 2, and A prime, C prime has 3. But again, now we know that B prime and E line up. Okay? Number 2. Now we're going to rotate. And we're going to rotate triangle A prime, B prime, C prime about point E, and this time we want C to line up with F. So we want segment B prime, C prime to line up with segment EF, which again would now mean that F is equal to C double prime. So I'm going to rotate counterclockwise this triangle up that way, about E, so that C prime comes all the way up here to F. B prime and B double prime are still the same, and for the meantime we'll rotate A up here to D, A double prime. And again, this would be the triangle. In a perfect world, it would line up, and again the sides would still be congruent, and we're good here because we know that B double prime and C double prime line up with E and F. But now the question is here, right? Do we know that A double prime lines up with D? And that's where this herky-jerky proof comes into play. So step 3. We need to prove that D is equal to A double prime. And to do this, we're going to do what's called an indirect proof. I touched on it a little bit in one lesson. So to do an indirect proof, you're going to assume that this is not true. So we're going to draw a picture here in a second where A double prime and D don't line up. And we want to reach a contradiction throughout this proof. If you reach a contradiction, then you can assume that you can say that what you assumed is not true, and that what you want to prove is true. So here's my picture. So I'm going to copy down triangle DEF as best I can. DEF. And now I'm going to put triangle C prime, B prime, A prime on there. So C prime and B prime are going to line up with F and E. So this is C double prime and B double prime. But I don't want A and D to line up. So I'm going to put A out here. A double prime. So again, we're assuming right now that these 2 triangles do not completely map onto each other. All right. So in doing this, the proof's going to need us to connect A double prime to D double prime. And let me put the congruences on there from the original picture. So from the original picture, I'll do it in purple. So DE and A double prime, B double prime would be marked congruent. B double prime, C double prime, and EF would be marked congruent. And then A double prime, C double prime, and FD would be marked congruent, right? That's the original drawings here. So when we connected A double prime to D, we created a couple triangles that are of interest to us. The first triangle is triangle A double prime, D double prime, F. This is actually now an isosceles triangle because these sides are congruent. So triangle A double prime DF is isosceles, which is going to mean that we have two congruent angles right here, these base angles. That would be angle F A double prime D would be congruent to angle F D A double prime. The same thing would happen over here with this triangle. I'm going to use green right here. This triangle would also be isosceles because it has two congruent sides. So triangle, and we call this one A double prime DE, this green triangle, is isosceles. So its base angles are congruent, which would be this angle here and this angle here. Notice that in each triangle, one of the angles kind of cuts the other angle from the triangle. So be aware of that as we keep going. So E A double prime D, E A double prime D, this angle would be congruent to angle E D A double prime. Now the idea here, so if we focus on like this red angle right here, so F A double prime D, and then this side E A double prime going through it, you know, when you cut this angle, the smaller angle must be less than the bigger angle, or the bigger angle must be bigger than the smaller angle. So based off this drawing, we know that the measure of angle F A double prime D, this corner angle, must be bigger than the measure of angle E A double prime D. And likewise, in the green triangle, we know that the measure of angle A double prime DE, this corner angle right here, A double prime DE, all right, would have to be bigger, so I'll use green, would have to be bigger than FD A double prime. I'm actually going to write that in a reverse order so it makes more sense up here. So let me reverse this. So the measure of angle, the measure of angle FD A double prime, FD A double prime, this angle right here, this small angle, would be less than the measure of angle A double prime DE, this corner angle. Well, what we can do here is we can take these two equations, and because these angles are congruent, F A double prime D and FDA, these two angles, and E A double prime D and ED A double prime, these two angles are congruent. And again, let me write this down, this angle. This is the same as ED A double prime. That'll make more sense. ED A double prime, that corner angle, it's up here. Because these angles are congruent, we can use some substitution and we can combine this. So we can substitute each for the other. All right, so I can take this and substitute FD A double prime up here to get the measure of angle FD A double prime. So I'll bring it up here, and I can keep that greater than symbol, and I can replace with the measure of angle ED A double prime. But if you notice here, when you do that substitution, now we've contradicted this bottom statement, because this one said they're less than, but because these are isosceles triangles and we substitute, this is a contradiction. So right here. So this proves that this, assuming not that they're not lined up, that's false. So we can conclude now that D is equal to A double prime. And there we have a rigid motion that exists, so that these two triangles are congruent. So all three vertices lines up. There is a rigid motion, which means that triangle ABC is congruent to triangle DEF, and side is good enough, and that's all we need. So again, I know that's a lot. I'm sorry to make you go through that. Hopefully something made sense in there. Again, it's this idea of having isosceles triangles and then cutting them. and making angles smaller than others. Okay, anywho, so we're going to go through a couple example problems here, and then we'll be good to go. All right, so here we go. It says, which of the following pairs are congruent by side, angle side, or side, side, side? So again, if you look here, one pair of sides, two pair of sides, three pair of sides. This is side, side, side. Right? And if you want to throw the little congruent symbol, that'd be great. Over here, so I have a side, I have an angle, and a side. Over here, I have a side, I have an angle, and a side. This is side, angle, side congruence. Down here, I have a side, I have a side, and I have an angle, right? So notice up here, this is side 1, angle, side 2. Notice down here, side 1, side 2, and the angle is not in between, right? The angle is next to it. Same thing here, side 1, side 2, and angle. This would be side, side, angle, which is not a congruence. So this would be neither. Neither. And then again here, side, angle, side, side, angle, side. This angle is in between. This is side, angle, side congruence. So this is what you need to be able to do, right, for these example problems. All right, last but not least, what additional information is needed to show that triangle ABC is congruent to triangle DEF by side, angle, side, by side, side, side. So let's hit side, angle, side first, right? So in this picture, so side, angle, side. So number 1. Well, in this picture, you already have one side, and you already have an angle. So you just need the second pair of sides. Now, there are two to choose from. In this picture, I need AC, because that would be the other side. That angle A would be in between those two sides. So I need segment AC to be congruent to. And now over here, same thing. Side, angle, so I would need this side, and that would be DF. Notice AC starts with a congruent angle, so DF. That's all you need, and that's side, angle, side. Now, for side, side, side congruence, well, you only know one pair of sides. So you need the other two, so you do need these two. So you would need segment AC is congruent to segment DF, but you would also need these two, BC and EF. You would also need to know that BC is congruent to EF. And if you have those two triangles will be congruent by side, side, side. So I apologize for the long explanation of that side, side, side congruence criterion. But again, if you can do these last couple problems, you're good to go. Okay, thanks for watching. We'll see you next time.